Hello and welcome to Getting Data from an API, part of the Building APIs with ASP.NET Core course. In this module, we'll walk you through building your first API endpoint to retrieve data. My name is Kevin Griffin. I'm an independent software consultant and 10-time Microsoft MVP, focused in ASP.NET development and deploying solutions to Microsoft Azure. It is my pleasure to teach you how to build APIs with ASP.NET Core. This module is designed to introduce you to some of the core concepts that make APIs possible in ASP.NET. We'll start with an overview of controllers and actions and the role they play in helping a request make its way into your code. We'll discuss dependency injection, as it's the glue that holds all of our infrastructure together. And finally, we'll jump right into code and help you build your first API endpoint. In this section, we'll introduce you to the concept of controllers and actions in ASP.NET Core. These are vital concepts for you to understand in your pursuit of building APIs. The concept of controllers and actions have been in ASP.NET since 2007, when ASP.NET MVC was first introduced. If you're new to the concept of controllers and actions, let's begin with a fundamental goal. We want to translate incoming HTTP requests into method calls. In the controller pattern, we use special classes, called controllers, to separate and contain logic for communicating with resources outside of our application. Inside of the controller, we have public methods, called actions, which help the controller direct traffic to an intended method. For example, I want the GET request to API/products to hit the action on my controller called GET products. The intent here is, based on the verb in the path, ASP.NET will create a new instance of my products controller and execute the GET products method or action on my behalf. But how does ASP.NET know what to do in these cases? We'll discuss this in greater detail in a later module, but ASP.NET Core has a robust routing engine whose sole job is to determine where your request should go. As your applications grow over time, you'll end up with dozens of controllers, each doing their own thing. Getting the correct action is only the first part of the equation. The controller is also responsible for making sure a correctly formatted response is sent back to the client that made the call. In this example, our action is returning a list of products with the status code 200 OK. We're going to spend a lot of time building and customizing controllers, but there are a couple keys to keep in mind. First, your controllers should be dumb. There should be very little business logic in a controller. If your API is designed to return a list of products, your controller shouldn't know the database where the products are. It shouldn't know how to connect to the database. Your controller should be able to ask a repository or a service to get a list of products, and then the controller can return them. But your controller should rarely have business logic inside of it. All the examples we do in this course will practice this concept. Controllers should validate inputs. We'll talk more about this in the future, but it's a simple rule in API design that you should never trust the client sending you data. Validate everything if it's critical to the application performing correctly. Now, there are great tools built into ASP.NET Core to assist you with model validation, such as requiring certain inputs to have values and ensuring those values are within reasonable ranges. Controllers should validate access. Remember, never trust anything from the client. That includes who they say they are. If you need to protect your endpoints, it's important that you ensure the requests coming in are able to perform the actions they're requesting. Imagine you're building a user's controller and you have a delete action that can potentially delete one or more users from your system. You'd like to ensure that anyone that makes that call is authorized to do so. In this section, we're going to cover dependency injection. What is it? Why should you use it? And how to take advantage of it with your APIs. I know what you're probably thinking. Why is dependency injection a topic on a course on building APIs? The quick answer is because you're going to use it everywhere. If you're new to dependency injection, let's discuss a little bit of what it is. We previously talked about that controllers in ASP.NET Core should be dumb or not have much business logic in them. But how do you go about telling your controllers where they can go to perform these actions? It's a best practice for this to be done via dependency injection. In the constructor of this sample controller, we're passing it a parameter of the type iProduct repository. Since it's an iProduct repository, we don't necessarily care about what the type of object we get. All it has to do is implement iProduct repository and we'll be happy. And from this code, can you tell me where the content of our get products call is coming from? Is it SQL Server, a flat file, or is it randomly generated? And you don't know, and neither does the controller. One important aspect of controllers is that you will never be responsible for newing up a controller instance. ASP.NET Core does this for you. But how does ASP.NET Core know what type of object to put into our iProduct repository? That's because we tell it when the application starts up. There is a special method in ASP.NET Core called configure services, and its job is to set up dependency injection throughout ASP.NET. In this method, we can tell ASP.NET Core that whenever one of our controllers or other services asks for an iProduct repository, it should create a new instance of a SQL product repository and inject it into the controller. A huge positive of this approach is that if you need to change the implementation of iProduct repository, say you move to MongoDB from SQL Server, you just need to write a new implementation and change one line of code in your configure services. All your other code should still work without issue. Let's walk through a demo to explain this concept a little bit deeper. In this demo, we'll walk through adding your own repositories and services via dependency injection in ASP.NET Core. For this demo on dependency injection, we're going to start with a couple things already created for us. The first thing is a states controller, and this is going to be an entry point into our application where we can pull out state information whenever we need it. Well, you can see here, I already have an action called getStates, and getStates will respond to any HTTP request to get/states. But we have a small problem. You can see by my to-do is that I don't know where to go get the list of states yet. And there's a couple different patterns you can use for the actual data access. You can use repository pattern, service pattern, you name it. It doesn't matter at this point. We're going to use a very simple version of the repository pattern, which I have started speccing out by creating an iStates repository interface. And interfaces are used in C# and within ASP.NET Core to identify the makeup of a contract of service or a repository. And we use this as a way for our controllers to communicate with the end actions. We don't necessarily know yet how our application is going to communicate to get this data. So let's just start with a very basic interface of how communication will occur. So in our interface, all we really need at the moment is a get method. So we'll return a list of states, and I've already created the states model, and we'll just call it getStates. Now let's go create an implementation of iStates repository. I'm going to call mine fake states repository because this is mostly used for testing data or just fake data. This isn't meant to be used in a real application. We'll do this a lot of the time to create or stub out fake data that we can use during the development process. And then once we've made decisions on where the actual data is going to preside, we will go create actual implementations of the code later. So a fake state repository is going to implement an iState repository. And I'll ask Visual Studio Code to implement the interface for me. You can see we have a list of states that's not currently implemented. So let me take a moment and just stub out this method. So there we go, a couple states. It doesn't need to be all 50 states. That's okay. This is just fake data that we can use. So we have an implementation. So we can go back over to our states controller, and we need to tell the states controller that we're expecting to get an iStates repository. And that is done through the controller. I can say iStates repository and just say, all right, I'm expecting an iStates repository, and pass this data in. Because the injection only occurs in the constructor, we're going to need this elsewhere. So I can tell my class to save this off as a private field. That way, any method that is called later on within this controller will have access to that repository. So then in my getStates controller, I can say var states is equal to states repository dot get states, and we can return the states through our OK. And there's one more action we need to take before we can run this and see it's actually working, and that's we need to tell ASP.NET Core what iStates repository maps to. How do we explain that whenever I ask for an iStates repository, I want an instance of a fake states repository? That happens in the startup CS file. There are two methods here that you usually care about, the configure services and then the configure method. Configure services is where all of your dependency injection setup needs to occur. Off of the services object that gets passed in, there's a variety of methods, and as you start adding things to ASP.NET Core, this list will get pretty robust with information. The couple that you care about when you're adding your own services for injection are going to be the add transient, the add scoped, and then finally the add singleton methods. What's the difference between these three methods? Well, let's add a little bit more context. Add transient means that anytime an instance of our iState repository is created, we're going to create a new instance of a fake state repository. It is possible during the life cycle of an HTTP request that iStates repository is going to be asked for multiple times. So it might not just be your controller, it might be other services that your service might need. There's a good chance that more than one item of the application lifecycle is going to need an iStates repository. Well, when that happens, add transient tells ASP.NET Core to create a new fake state repository every single time. This is really useful if your backend data access layer requires that you open and close connections on demand. So when you're done with the connection, throw it away. You don't need to worry about long scale access being available. Now, add scoped takes that a little bit deeper. When you ask for an iStates repository that's scoped, it means that a new instance will be created per request. Let's talk about that a little bit more. When a request comes into getStates and our controller asks for an iStates repository, one new instance of iStates repository will get created. Anything else that asks for an iStates repository after the first one is created will just get a reference to the previously created iStates repository. So they'll share the states of the one generated iStates repository. This is useful in actions where maybe you have some sort of transaction during a request. So the request gets generated, a transaction is opened, you do all your work, and everything that needs to do work in a database goes and does that work. And then at the end of the life cycle, when the request is done, the transaction gets committed and shut down. Or if anything goes wrong, that transaction can get rolled back and it doesn't affect all the steps in between. So that's a good use for a scoped injection. Singleton is what you probably think it is. When an iStates repository is requested for the first time, only one instance of a fake state repository will ever get generated. And that one instance will get passed around to anything that ever asks for an iState repository in the future. So this is really useful if you have certain services or repositories that only need one instance to ever be created. A good example, if you want a real life example, is if you're talking to something like Redis, where you're expected to have one database connection for the life cycle of your application. You just want to create it once and leave it open forever. For our demo, and most of the demos I do, add transient is all we need. We don't mind that it's created every single time. Let's go ahead and take a look at this in action. So I'm going to bring up a new browser, and my application is running in the background. We'll go to our domain/states and hit enter. And this returns the list of the states that I have. Let's also take a look at this behind a debugger just so you can get a better sense of what's happening. I'm going to start the debugger in VS Code. I'm going to go to my states endpoint. And you see the first thing that happens is I hit the endpoint in my constructor. ASP.NET Core is passing in a fake state repository because that's what I told it to do in my startup.cs. I'm going to sign that away to a private field. And then ASP.NET Core calls into my getStates method. And we see again, it's going to talk to the states repository that got stored away earlier. This returns a list of states that we are expecting it to return. And that gets sent back out to our client. Now, sometimes you have use cases where you don't want to do the injections every single time a controller is newed up. And there is a way to do injection in ASP.NET Core on an action by action basis. So let's go ahead and remove all this code from our constructor. And let's go into the getStates method and tell the getStates method it needs to go get an instance of an iStates repository by itself. In the method signature for getStates, we're going to add the iStates repository injection there. But we have to do something special. At the beginning of it, we need to add the attribute from services. And what this does is the injection only occurs when this action gets called. So this is really useful if you have controllers with a whole bunch of methods, or if you have certain injections that are a little bit more expensive than others. Because you have to remember that for every injection that you do, this is a couple milliseconds that ASP.NET Core is going to take to new up your new injection and actually inject it into your controller or service. If your controller has a dozen or so injections, this could take a very small amount of time, but build this up over hundreds or thousands or millions of requests. That stuff takes time. So if you don't need it for every single action in your controller, don't inject it all the time. Inject it only where you need it. So we run through this demo again, and we'll hit refresh. This time we're hitting just our getStates action and looking at the states repository. It's passing in just the fake state repository, and this doesn't get passed into anything else. So that is dependency injection in a nutshell. We'll see you next time. In this section, we'll build out a simple GET request with ASP.NET Core and walk through a couple of the moving parts. Here's an example of a simple functional API in ASP.NET Core. As you probably notice, it's a simple class. But let's look at some of the pieces required for this class to work as a controller in ASP.NET. ASP.NET Core identifies controllers in your application by looking for classes that implement the controller class. This implementation provides you with all the tools you need to handle multiple types of requests. Side note, you can also use controller base for your implementation. The big difference is that a controller contains logic for returning views, or Razor syntax. With API development, this isn't something that you need to worry about. So it's a small optimization to implement controller base instead of controller. Either way works for any of the demos that we do, so don't worry about it. Your eye is probably drawn to the decorators on the class and on the action itself. The API controller attribute is used to help give ASP.NET Core a heads up that you're specifically building an API. It'll do things like enabling automatic 400 bad requests if your model binding isn't valid. It will help assisting you with binding data to models, and it'll also provide better error support and details when those occur. The route attribute and the HTTP GET attribute tell ASP.NET Core which paths and verbs should direct to this controller, and specifically which action. We have an entire section on routing, but this example says that the products controller handles all requests that begin with API/products. But it doesn't specify any verbs. The GET action does though, by adding an attribute that says that any GET request to this controller should go through the GET action. Note, in most cases, the name of the method doesn't matter, but we'll cover that more later. If someone were to make a GET request to API/products, ASP.NET Core will instantiate our products controller and call the GET action. This action will make a call to our products repository and return the results. And the return statement is special too. Returning the OK method creates a 200 OK response with the content of the products as the payload. This list of products will be converted into JSON and sent to the client for use. Now let's walk through a simple GET request with a demo. In this demo, we'll walk through building your first GET request with ASP.NET Core. So you're ready to create your first simple GET request with ASP.NET Core. I've already taken the liberty of doing a little bit of setup in this sample application. This is a basic ASP.NET Core web application, and I've added a states controller. So my states controller inherits from controller base because this is only going to focus on API based calls and not have anything to do with views or Razor based calls. Now my states controller is going to take in an iStates repository via dependency injection. So anytime I need to get information about states or geographical data in the future, I can use this repository to do that. And I want to create an action that responds to the GET states request. Now let's create an action that does this for us. All actions are public facing methods, and mine is going to return an iAction result. We're going to call it GET states. Now, in order for ASP.NET Core to understand what's going on, we have to add a little bit of direction. On the states controller itself, we're going to add two attributes. The first one is API controller. This attribute tells ASP.NET Core that the states controller is specifically for APIs, and it's not going to do anything that's view-based. We get a couple little helpers out of this, but it's good practice to put it on all your controllers if they're API-based, but it's not really a necessity. The other thing I want to do is set the route for the controller itself to states. Down on the getStates method, I need to tell ASP.NET Core that this method is going to respond to an HTTP GET request and leave the route empty. Because I have a route on the states controller, ASP.NET Core is automatically going to assume that this is the prefix for any actions within the controller. Inside of my states controller, I need to go get the data, because once we've gotten to this point, ASP.NET Core has already figured out this is where the request is supposed to go. So I'm going to go into my states repository, and I'm going to call the getStates method. And remember, controllers are supposed to be dumb. They aren't allowed to contain business logic, or at least they shouldn't contain business logic. They just need to go off to the places that do have the business logic and ask them for the data that's required. So my states repository is an interface to something down the line that will have states information, and we'll return it via a 200 OK. Now, because we're returning an iAction result, and we'll talk more about result types in a later module, but an iAction result, I can return an OK action result using the OK method. Now, I can return OK just by itself, but since this GET request is expecting a list of states as a return, I'll return the list of states. Let's go ahead and run our application. So we'll bring over our friend Postman and we'll load the potential API endpoint, which is going to be a GET request to our app/states. I'll hit send, and this will return the list of states in JSON format. If you like to see this another way, I can go into the states controller in VS Code and we'll set a breakpoint on line 19, which is the call to get states. I will hit F5 to put it in debug mode. We'll head back over to Postman and we'll hit send one more time. This time our breakpoint hits in VS Code, and you'll see I'm making a call to states repository, which is an instance of fake state repository. And I will hit next. That will return our list of states, as we can see inside of IntelliSense. And then I'll return the 200 OK. So this response is sent back to Postman, and we're happy. We're seeing we're turning a 200 OK. So there you go. That is a simple HTTP request built in ASP.NET Core. Now this is just a starting point. We're going to get way more complicated than this, so stay tuned. In this module, we covered how controllers and actions work as a means for responding to web requests. We discussed dependency injection and how it is vital to how ASP.NET Core applications are held together. We can use dependency injection to our benefit by keeping implementation details out of our controllers. And finally, we built out a simple GET request using ASP.NET Core. Thanks for listening to the Getting Data from an API module, part of the Building APIs with ASP.NET Core course. My name is Kevin Griffin.